This week, Dick and Jem take on their most ambitious challenge yet. They plan to harness the power of our planet's biggest natural resource.
Oh, feel the sun off that.
They'll be tapping the sun using both ancient and futuristic technology, with a dash of daredevil sci-fi thrown into the mix.
You do complicated, I do simple.
But can they succeed in conjuring up solar energy? Or will they end up just getting very badly burnt?
We've pushed the boat so far out with the Stirling engine, we can't even see the shore.
Dick Strawbridge is an ex-army officer turned eco-warrior. Jem Stansfield is an inventor with a wild green streak. Whoa! Two men on a mission to fix the world. Whoa! One mechanical solution at a time. Together, they are the Planet Mechanics. Dick and Jem's biofueled mobile workshop has travelled almost 3,000 kilometres across Europe. Our eco-engineers are seeking out sunshine, and they've certainly arrived in the right place. Andalusia, the most southerly and hottest part of mainland Spain.
If you think about it, southern Spain, Andalusia, sun all the time. Just think the potential they've got.
Potential energy, yeah, but practically turning sunshine into useful work is phenomenally difficult.
Yeah, but we're up for a challenge.
Culturally vibrant, Andalusia was once one of the poorest parts of Spain. But sunshine is one thing that it's always had in abundance. The Spanish call this region the frying pan, and Dick and Jem are beginning to realise why.
It's more like the double oven of Spain, though, because it's blasting in from the top and then welling up from underneath.
Spain is determined to use this natural resource and become a world leader in solar technology. And now Dick and Jem have caused sun fever. They want to use it to help green up this traditional finca.
I think we've reached the homestead.
I'm quite jealous of the guy already. He's got a castle.
The Planet Mechanics have been called in by farm owner and solar pioneer Jesus Martinez.
Hello.
Hello.
Very nice to meet you down here.
Hello, I'm Dick. Nice to meet you.
Yeah.
Come with us. Show you all the finca now.
Jesus' idyllic 500-hectare finca certainly looks like a conventional Andalusian ranch, but there is nothing old-fashioned about his plans for the future. Jesus has set aside waste ground on the edge of the finca to produce the one crop this part of Spain is crying out for: clean, renewable energy. And this is how he'll do it. His solar farm will look like this: 34,000 solar panels producing 3 gigawatts of electricity. The Spanish government subsidizes green energy, so the local power company should be keen to buy Jesus' solar power. It will be used to meet the power demands of tourist developments mushrooming along this coast. But first, Jesus is keen to sort out a problem much closer to home.
Hey!
And that's why he's called in the Planet Mechanics.
Do these horses speak English?
Hey girls, how are you doing?
Jesus is understandably proud of his herd of beef cattle, but supplying 100 thirsty cows with drinking water is giving him an environmental headache.
They drink a lot, something like 50 liters a day, every cow. Water is not the problem. The problem is the pumping.
Okay. If we've got a well to see, that'd be great, isn't it? Yeah, that'd be nice, because I don't know how long my bottom will last. That's right.
The cattle are happy with the water, but how they get it, that's the problem.
Hey Antonio, how are you doing?
Antonio, I'm Dick.
Running the pump operation is the job of Jesus' all-round right-hand man, Antonio.
And there is our local John Wayne.
Antonio draws drinking water using an antiquated fume-belching diesel pump. It's not exactly environmentally friendly, and Jesus wants rid of it.
It's smelly, it's old, it's dirty, it's a diesel.
That's not far off being a fire pump. That running for an hour is an awful lot of water. I mean, that's a big thing to replace.
Trying to do that with green energy is a challenge. From that distance, that much water is hard.
It's not that we're shy of a challenge, but that's a big job.
Jem is looking crushed. But Colonel Dick is not ready to run up the white flag just yet. he's thinking Plan B.
Is this your only well that's working?
Well, we have a small well, but there is nothing. It's not working at the moment. No pump.
Can we see it?
Why not? Yes, let's go.
So it's back in the saddle for another bone-shaking trip across the parched finca.
This looks much more like the kind of well I imagined.
All hopes are riding on the abandoned smaller well.
Why is this not in use?
Because, well, we have no cows here because there is no pumping motor.
So if you could pump the water out of here, you could have cows in this field.
That's right.
Why don't you do that?
Everyone agrees the small well seems to be perfect. Now Dick and Jem have to work out the not-so-minor detail of how to pump water in an environmentally friendly manner. They could use photovoltaic solar panels, but Dick and Jem didn't travel all this way to come up with such an obvious solution.
So photovoltaics, you know, it's old hat. Jesus knows about it.
Jesus said that he's going to have a whole field full of solar panels. I think he would be very disappointed if we came back to him and suggested that he put another solar panel there.
So that's not got any innovation to it. OK, something else.
Well, there is a concept out there called the Stirling engine, and it does just run on hot air. So all you would need, in principle, is sunshine making hot air, and that would do everything.
The key principle of the Stirling engine is that a fixed amount of gas is sealed inside a chamber within the machine. This gas is alternately exposed to heat and cold, causing it to expand and then contract. A mobile displacer controls the alternating cycle of expansion and contraction, which is used to drive the engine. The energy is used to power machinery. In Jem's case, a pump to draw water out of the well.
You get Stirling engines in top-of-the-range nuclear submarines.
In theory, a Stirling engine can be an extremely quiet, efficient way of converting heat into movement. And if that heat is provided by sunshine, they can be pollution-free too. But complex Stirling engines are expensive to build, usually requiring the resources of high-spec organizations such as NASA or the military.
We're in a finca in the middle of nowhere with a horse box. We've got a couple of days. Do you really think we can do that?
Maybe we can take the principles of the Stirling engine and make it in a more simple way. Do you not think Jesus would absolutely go wild for it, though? He would then have an incredibly interesting piece of kit that literally no other finca in Spain would have even thinked of, if you know what I mean.
But down-to-earth Dick is seriously worried about Jem's flight of fancy.
We need a backup.
Yeah, normally, Dick, I'm not in favour of a safety net, but I think on this occasion, we've pushed the boat so far out with the Stirling engine, we can't even see the shore.
Jesus said this is the windiest part of Spain. Let's use the wind. Something simple. A wind pump?
To get the water pumping, Dick is proposing to build a traditional windmill. A windmill is powered by a set of rotating blades. The energy created by the spinning blades causes a shaft to rotate and move a crank up and down. The crank is connected to a piston pump that will pull water up from the well. The technology may be straightforward, but building a windmill is an enormous challenge. And Dick will still need plenty of sunshine.
We are still using sunshine, because it's the sunshine in Africa that generates the heat that makes the wind blow over Jesus' finca. I'm using Spanish sunshine and you're using exotic African sunshine.
The time for talking is through. It's high noon at the finca. Colonel Dick will need to bring out his heaviest guns to manufacture a traditional windmill in just a few short days. But young dude Jem thinks he will be the first to the draw with his newfangled hot air Stirling engine. The Planet mechanics have come up with radically different ways of pumping water from a well. But first, they must team up.
Swing it in there. Ooh.
And get their Eco Workshop horsebox up and running and ready for business. With the relentless Andalusian sun belting down, our Planet mechanics are positioning their truck in some much-needed shade.
I mean, I'm thinking Because of the heat, shade's going to be more important to us. I think we'll forget about the wind power and just make sure the solar panel's giving us as much as possible.
Yeah.
Good man.
Manufacturing a Stirling engine and a windmill is going to be a Herculean task. They've got a truck full of tools, as many raw materials as they could transport, and all of their own engineering wit and ingenuity. Everything else will have to be scavenged locally. Jem's come down to earth with a bump. He's finally beginning to realise the enormity of the challenge he set himself. Stirling engines are usually built in high-tech laboratories. He's got to make one out of the back of a truck. Dick's also got a mechanical mountain to climb. He's got a few short days to manufacture a high-spinning windmill. He spotted a batch of old barrels and he thinks he can recycle them to produce a set of blades. It's a smart move. The steel is tough, lightweight, and the concave shape means the blades can capture wind much more efficiently, giving his windmill a better chance of getting moving. A big bonus for Dick is that he won't need to spend time building a tall tower for his windmill. The well is situated on a wide open plain, which receives the full force of the Levanta, the strong wind that blows in from North Africa. Out here, a low-rise windmill should catch lots of unobstructed wind. To be out of the cattle's way, the spinning blades will have to be short. Short blades catch less wind, so Dick will need more of them. But more blades will create drag, which limits top speed. But Dick doesn't care about speed. He knows more blades also means more torque or twisting force. That rotary force will then be converted to drive a piston pump up and down, drawing water from the well. Dick has rustled up an extremely strong disc that he wants to use as the spinning hub at the heart of his windmill. Now he's got his hub, he can work out how many blades he can use. The more he can fit, the more power he will get. When the blades are attached, their spinning motion will turn the shaft mounted in a pair of bearings.
Blades on here, centre somewhere about there, goes around, water pumps.
Nice.
It makes you wonder why I'm going to take so long to finish it.
Dick may sound confident, but he's got a very long way to go before his windmill can draw in the cows. But at least he's happily getting his hands dirty. Jem's Stirling engine is still stuck at the R&D stage. To cheer himself up, he's got hold of a desktop Stirling engine to demonstrate the principles of his amazing hot air machine.
It'll work off the heat from a cup of tea.
Oh.
But even then, it doesn't quite start itself. So there we go. So the heat from your tea keeps this plate hot, and the air keeps this plate cool. And the little insulating piston inside moves the air from the hot side to the cold side. And in doing that, the air expands and contracts.
When the hot air gets to the top of the cylinder, it rapidly cools and contracts, forcing the displacing piston down. This continuous cycle of expansion and contraction drives a second smaller piston, which provides mechanical power to turn the wheel.
So I figure if I'm going to make you a Stirling engine that has any chance of pumping water, it's going to need to be thousands of times bigger than this.
But Jem is still desperately trying to work out just how he's going to manufacture his version of a Stirling engine.